So we're going to talk about reaching asynchronous Cloud 9 in JavaScript with generators, which is basically a fancy way of saying we're going to make JavaScript not suck. But first, one thing real quick, I work for a company called Segment.io, and if you want a really cool shirt like the one I have on, or a really cool sticker like that, you can come grab one afterwards. So asynchronous programming really sucks sometimes. Sometimes it feels like juggling all these callbacks feels a lot like this guy here trying to throw a boomerang. You know, because you have to just pass values and pass behaviors around, and you end up with just, you know, a small example. You end up with code that looks like that, and it's not fun to maintain at all. I don't know about you guys, but I get kind of irritated with it because when you go to change things, you end up doing things like that when you try to refactor your application. And it's just, it's a pain. And you're supposed to kind of, people say you're going to fix it with promises, but, you know, we can see this application with promises. It's just a pyramid of promises instead of callbacks. And that kind of sucks too. And when you kind of put this all together, you're like doing this this balancing act of all this coordination, right? And it just seems like it's a lot harder than it has to be. And I started finding myself frustrated because you seem like instead of focusing on your business problem that you're trying to solve, you've now created this code problem, and you're like spending all day trying to figure out what needs to be synchronous, what needs to be sequential, and now you're solving that problem instead of what you get paid to solve. And that's just irritating, and you end up just wanting to smash your keyboard against your computer. So thankfully, there is a better way, and that's with generators, which is in the new, what they call ECMAScript 6 edition of JavaScript, which is kind of the new features that are slowly being rolled out. The ironic thing is generators aren't really meant for asynchronous programming at all. And we're just going to make them work anyways. And there's a lot of frameworks built around them, and everybody's kind of jumping on board. Because they're there, and we're going to make it work, kind of like this kid with his toys. So since they're not really meant for asynchronous control flow, we're going to kind of go over some of the basics of how you can make them work to your advantage. And then you'll kind of understand some of these new tools in the Node community, at least. That's kind of where I focus, like Co and Coa, and how they actually work and how you can kind of leverage those in the future. And by the way, if you have any questions, you can kind of just interrupt me. So no biggie. I'm going to kind of assume you have some JavaScript knowledge. Most of this stuff, it can work with Node or in the browser, assuming it's a modern browser. But we'll kind of talk about some of the tools you can do to get around that. So, a generator. The basic generator looks like your normal function, except you have this little asterisk at the top on the name, and then we have this new keyword called yield. And other than that, they look the same. We just have some new syntax. When you invoke it, you can just assign it to a variable. And then you have this new method called next. And as you call next, you get values back. And it's an object with a value property and a done property. And the value property is going to be whatever you yield. So in this example, we yield 3 times. So as we run it, we get 1, 2, 3, and then the last one is undefined. However, you'll notice done is true now. So if you've ever used iterators before in another language, it's actually built on top of iterators. It's just kind of, there's some magic going on behind the scenes where yield and next are able to coordinate the iteration. So not only can you send values back, you can also send values into the generator. So here, same exact thing, except now we're yielding, and then we're getting a value back from yield. So basically, what we see here is when you first create the generator, the very first time you call next, you wake up the generator out of its suspended state. Because when you first create it, nothing happens. So if we didn't call it.next on that first line or any below, we would have no output. However, the first time we call it, we'll get here, and then we'll get that value done in 1, and then it would stop. But since we call it again, we get the value A received back out of the yield, because it basically freezes up to right after the yield, and it goes back into suspended state.
So I noticed like the syntax you're using inside the generator is A equals yield. Is there any way for that to work with, like your first call to iterate.next doesn't have an specific order? Is there a way to get that value inside the generator?
No, because your first iteration is going to take it up to the yield, and then right before the assignment happens, it's going to go back into suspended state. And then that next call, it's going to take the value that you're passing in next, and it's going to have it, and then it's going to go to the next yield stop, and then the next one.
So that's just sort of a limitation of generators. You can't, like the first time you call next,
Yes. Yeah. Yeah. And we're going to kind of go over the sending values pretty quick, because as we get into the asynchronous programming, there's not a whole lot that we're going to do with it for our example. But the third really interesting thing with generators is it also has a throw method on the generator. And you can throw an error inside of the generator. So in this example, we're going to iterate up to the first time, and then we're going to throw an error. And you can see here that we got our first iteration out, but then we get an exception thrown. And you got to trust me, because I don't want to go back and forth between the code editor, but stack trace actually lines up to where the yield was, which is pretty nice, because then we can actually put a try catch inside of our generator, and we can try to yield something, and if something uses our generator throw, we can actually catch what they're throwing. And you have to put that in the back of your mind for now until we get back to how we can use that for asynchronous programming. Which you're probably wondering by now, WTF, what does this have to do with async programming? You're talking about iteration and generators. However, if we look back at some of the basics of asynchronous programming and kind of JavaScript, we'll be able to draw some pretty close parallels. And if you understand those basics, then you can apply generators without a problem. So here we have kind of just a simple problem, just 3 functions that just do kind of a set timeout and logging. I didn't want to go complicated with databases and all that, so just a simple problem. But then in the bottom here, we're just going to call them in a row, right? 1, 2, 3, console.log. And does anybody want to guess what the output of that's going to be? Yes. So it's not in order, right? Because it's asynchronous. Yeah, it was, sorry if you couldn't hear, it was done 2, 3, 1. So, and that's because everything's asynchronous, so in order to have sequential order, what do we use in JavaScript to be able to call something and then call the next thing, right? We have to use callbacks or promises or, some variation. So we go back to our 3 functions, and we have to add a callback to each of them. And it's all pretty simple. Just got to pass in a function as a value, and then we'll just invoke it. And then a horrible way to use it would just be you nest it. And that's how you end up with the whole callback hell stuff. We just call each one, and then we pass a callback function, which will call the next one, and the next one, and the next one, which is kind of probably the way you wrote code the very first time you tried to write an asynchronous app. But then there's tricks to make that not so nested and crazy, and these are the tricks that some of the libraries like async use, but they handle a lot more cases. Because what we want to do is basically take 3 functions and run them in a row, right? And now that we've added a callback, we can just have a utility function that can do that for us. So if we skip the top function, but look how we're going to use it, we just have this run function, and we're going to pass it this array of 3 functions. And what that utility is going to do is call those in order, and it's going to have this internal next function that just recursively calls the next one until there's no more functions left. And when there's no more left, it just calls our done function for us so we can do something afterwards. Pretty straightforward, right? Makes sense? So if you're kind of thinking, like, wow, this whole iteration until you're done, it kind of sounds similar to what we just talked about with generators. And if you thought that before I said it, you're awesome. If not, we'll get there. And we'll talk about how we can make it work. So we can just change our run function to utilize what we just learned about generators and apply the very similar concept, but instead of popping off functions from the stack, just call generator.next. And we just learned with next, it just takes the value that gets sent back from yield. Now with yield, you can yield anything. So what we're going to do is we're going to yield functions. And then our utility function is going to grab that function that's been yielded to it and call it. And then do that same recursive trick where it just passes itself to that callback. And then as soon as it's done, we just call the done function. Or just return, actually, because we don't have to call a callback. So again, if you're thinking you can yield anything, you're correct. We can yield other generators. We can yield objects, arrays. We can really yield anything, I think, except for an undefined value. So doing that's a little more complicated, so we're actually not going to write that in our done function. There is libraries that are built by really smart people that have done that. And one is called Co, which does basically what we just did. And here's an example of it being used. So this is Node, by the way. So it's a Node module, so you just require it, and you pass in your generator function. And it will run it for you and figure out all the yields and do the sequential or parallel processing based on the values you give it. But in this is a simple example. Rather than our callback 1, 2, 3, we actually wrote those as generators. And we pass the generator to yield, and Co resolves that for us. So in the first one, after it's created, we do this yield sleep. Well, what sleep does is it just returns a function that accepts a function that after a certain set time out, it continues. And Co will traverse that, and then once it's done, we'll move on to the next one. And just does the whole next iterator dependency tree all the way down until there's nothing to next. And we'll look at some more kind of more advanced examples of what you can do with it on their site. But before I forget, other tooling. So all of these can be used in Node 11 or above. I think it's Node 11.3, but the current version is 11.13, which it says it's unstable, but we use it in production and it works great. And you have to pass this harmony flag to it since that's part of the ES6, and that's how you turn it on. And The latest version of Chrome has them, and the latest version of Firefox. And then if you need to work with older browsers, there's this really neat tool called Regenerator. And I just spelled generator. Sorry, I misspelled that. But Facebook built this tool that basically will compile your generators using it's a node module called like Esperima. So it takes the syntax tree of generators and then rewrites it as callback functions and then just dumps it out. So you can compile a really nice looking app for older browsers. But along the lines of tooling, where's the object example? Down here. Yeah, so you can yield objects or arrays, and Co will traverse the object and inspect every property and call those for you. So if you just want to create like an instance of a class in JavaScript and just have all your methods that you want to be called, it will figure that out for you. And arrays will be iterated in parallel. So if you have like an array of a bunch of requests you want to make, you can just yield that array of all the outgoing requests, and it will resolve each one. And after the last one is done, it'll continue on. Go back into presentation mode. All right. So, any questions? I kind of flew through that really quicker than I thought I would, so go for it.